Okay. Let's see. We got 25 to 37. Looks like a word problem there. Doesn't look too bad. Let's shoot for 20 minutes. I like that 20-minute homework. Always seems reasonable. Anyways, we have 16, 12, 75. This is angle addition, and we know sine and cosine and possibly tangent. I might have to look up tangent, but secant we don't know. I'm sure there's a formula. If there's probably a textbook out there that has an angle addition for secant, but remember secant of something, secant of theta is just 1 over cosine of theta. So we're going to do the cosine angle addition formula, and then we're going to reciprocate it, and then we'll get the secant answer. Not that big of a deal. Anyways, this angle is well past our 360 degrees, so I'm going to subtract off a bunch of 360 degrees until I get in between 0 and 360. Kind of the coterminal thing. At the same time, I should know, let's see, 360 times 2 is 720. Add another 360, you get 1080. Add another 360, and then we're over 1275. So I'm going to take my 1275, and I'm going to subtract off 1080 and get its coterminal angle that's, within 0 and 360, I guess. So here's 5. Got to borrow. This becomes 9. This is 195. Let me double check. 195, 1080 times plus 1080. I mean, that sounds good. Don't know why I need to triple check. I'm gonna triple check. Okay, so now we can come up with a, obviously we're gonna do angle addition formula for cosine. And I need 2 angles that add up to 135, or when we subtract, we can get 195 as well. So we can do either addition or subtraction, but I think generally addition's easier. And I know someone might be what about 180 and 15? We can't do 180 and 15 because 15 is not on the unit circle, so it doesn't really help us. So let's do 150 and 45. 150 plus 45. I believe that'll give us 195. So I'll do 150 plus 45. And then I just do the angle addition formula. So I'm going to rewrite it here using that cosine. So it's cosine of 150 degrees times cosine of 45 degrees minus sine of 150 degrees times sine of 45 degrees. And I believe these 2 sines are always opposite of each other when it's dealing with cosine. They're the same when you're dealing with sine. All right, and then we've got to figure out what cosine of 150 degrees is. 150 degrees would be, its reference angle would be 30 degrees in the second quadrant. Cosine of 30 degrees is rad 3 over 2, but it's in the second quadrant, so this is negative rad 3 over 2. Cosine of 45 degrees is just rad 2 over 2. Minus sine of 150 degrees, that's in the second quadrant, it's going to be positive 1/2. And then sine of 45 degrees, that's rad 2 over 2. So this will be negative rad 6 over 4 minus rad 2 over 4, which would give me a negative rad 6 minus rad 2 all over 4 as the answer. But I'm going to double check the answer. Make sure we're good. Let me pull up the answer key. Oof. Okay, so we're not solving for cosine, so what we have to do with this is we have to reciprocate it. So remember, we're trying to find secant of 1275 or something, I forget. Yeah, secant of 1275, which is equivalent to secant of 195, which is equivalent to 1 over cosine of 195. So we actually want to reciprocate our answer, so we're going to get 4 over. I'm going to factor out the negative. This is going to be a little weird, but I just don't want to play with the negative. So I'm going to put the negative up here, and down here I get the square root of 6 plus the square root of 2. Again, I factor out the negative from the top, and I just moved it here. And unfortunately, this isn't the answer in the textbook. The answer in the textbook is the square root of 2 minus the square root of 6. But we'll get there. So what do we have to do? Well, the answer in the textbook is rationalized, so we're going to multiply by the conjugate. So we get radical 6 minus radical 2 over radical 6 minus radical 2. And this homework is going to turn into a long homework. So this is negative 4 times radical 6 minus radical 2 all over. And then down here, you're going to get the square root of 36, minus the square root of 4. Minus the square root of 4. There we go. And the square root of 36 is 6, and the square root of 4 is 4. So you get negative 4 square root of 6 minus the square root of 2 over, again, this is 6 minus 2, which is 4. These 4's cancel out. And I eventually get an answer of negative rad 6 plus rad 2 as my answer, and that's the answer in the back of the book. It took a while. It definitely did. We haven't had a 5-minute problem in a while, but there it is. 27. Okay, same idea. This is definitely less than 2 pi, because if it was 24 pi, it would be 2 pi. So we want tangent of 23 pi over 12 pi. And again, I can do like 24 pi minus 12 pi, but you don't know what minus 12 pi is, like you can't, or 12 over 1/12 pi. Like you don't know what that value is. So you want to like change this in the values we do know. So 23, 18 and 5. No, we need another one. 19 and 4 now. 3 and 20. I like that. So we're going to write this as tangent of 20 pi over 12 plus 3 pi over 12. And I basically I guess like my rationale was I want to pick two numbers where we break it up into partial fractions and it simplifies, it reduces, because I want to reduce it down to pi over 6 or pi over 3 or something like that, or pi over 4. So I'm going to go ahead and do that. And that does add up to 23 pi over 12. And I guess if like you're having a lot of troubles with this, you could change it to degrees. It might be easier. I'm not sure. So anyways, we got tangent of, 20. So I'm going to reduce this by 2. I guess I can reduce it by 4. Yeah, this is 5 pi over 3 plus pi over 4. In this point, I really do like, I don't know what I was going to say. Radians. I'm more familiar with the unit circle and radians, but we'll see. Angle addition for tangent. I'm going to cheat and look it up. I'm pretty sure it is. You like add the two tangents and then you do one minus the product of the other. But I'm going to triple check. And I don't want to derive it right now. Okay, yeah. Tangent addition. All right, so then I'll get tangent of 5 pi over 3 plus tangent of pi over 4 over 1 minus tangent of 5 pi over 3 times tangent of pi over 4. I'm pretty sure, like as a student, I'd like just worked with sine and cosine, and I write tangent as sine and cosine, but I'm going to go with this. All right, 5 pi over 3, that's in the... All right, that was an interesting try. I lost a negative, and then it just became super terrible, so I was just going to start from, I don't know, some point. Anyways, whatevers. All right, so where I lost a negative, I lost it on this tangent of 5 pi over 3. I think a tangent of sine over cosine. So like tangent of 5 pi over 3 is in the fourth quadrant, so it's going to be like a negative rad 3 over 2 over 1/2 against sine over cosine. Plus tangent of pi over 4, well, that's just 1. Or if we want rad 2 over 2 divided by rad 2 over 2. And then we got 1 minus, I'm going to simplify this. I don't want to write it again. That's just negative rad 3. So let's see, negative rad 3 times 1. So there it is. And we just have to simplify this garbage. On top, we'll get negative rad 3 plus 1. On bottom, we'll get 1 plus rad 3, I believe. I'm going to rewrite the top here as 1 minus rad 3. I don't know why. And on the bottom, I'll write 1 plus rad 3. This obviously isn't the answer in the back of the book. I'm going to rationalize this thing and then hope for the best. 1 minus rad 3, 1 minus rad 3. This is equal to Let's see, 1 times 1 is 1. This is minus rad 3. This is minus rad 3. This is plus 3 all over. That's difference of 2 squares. It should turn into 1 minus 3 because this will be the square root of 9. And then I just start dropping things in here. So I get 4 minus 2 rad 3 over negative 2. I can divide the top and the bottom by negative 2 or factor out negative 2's, or I don't know, however you want to do it. This would be negative 2 plus rad 3 when I factor out a negative 2. And this will be over negative 2. And the negative 2's cancel out. And we get negative 2 plus rad 3 as our answer. And that is correct. I double checked. 29. Wow, this is long homework. I'm hoping for 20 minutes, but it doesn't look good. Ugh. Okay, no. I'm fine. So cotangent of 113 pi over 12. I mean, this is going to be equal to 1 over tangent of 113 pi over 12. So we're going to solve for 113 pi over 12 for tangent. And then at the end, we're going to reciprocate that answer. And then we're going to have to rationalize and stuff like that. So let's talk about tangent of 113 pi over 12. Let's see. So if I count by 2's, and in theory, this should be easy. That should be easy. If I count by 2's, okay, I had to do some side work to make the numbers work out. But basically, we want to look at multiples of 2 pi. So it turns out that tangent, or 113 pi over 12, you could subtract off 96 pi over 12. And the reason I subtract off 96 pi over 12, because this really reduces by 8 pi. And so it's like going around the circle 4 times. So I'm basically subtracting off a bunch of 2 pi's. Like the next 2 pi would be 120, but it's too much. So it's at 113. So I'm going to, whatever this result is, when I subtract, again, I'm subtracting off by 2 pi's, a bunch of them, in this case, 8 2 pi's. The result is going to be coterminal to 113. And I believe if we do the math real quick, 113 minus 96, borrow 13, 7, borrow, let's see, this is 0, 1, 17. So this is equivalent. This is coterminal to 17 pi over 12. And I'm going to be honest here. It took me a little bit to how do I break up 17? I was 10 and 7, but then the 7 over 12 doesn't reduce. So you have to pick 2 numbers that will reduce by 12, or by a factor of 12 at least. So what 2 numbers are those? I believe tangent of, 8 and 9. 8 pi over 12 would reduce, plus 9 pi over 12 would reduce as well. And there might be a difference one that might be easier, but I just went with that. Yeah, just went with that. So I'm going to go ahead and reduce those values. So I'll say tangent of, I believe that's going to be 2 pi over 3. Plus, when I reduce this, I can reduce it by 3. And that's 3 pi over 4. And then I just have this, equation I have. Let's see, tangent of 2 pi over 3 plus tangent of 3 pi over 4 all over 1 minus tangent of 2 pi over 3 times tangent of 3 pi over 4. That type of dance. Excuse me. And then I just substitute in. Again, this is the pi over 3, so it's going to turn into that root 3. I'm in the second quadrant, and I believe that's going to be a negative value. So I'll get negative rad 3 plus. Okay, so this is going to be some form of 1. This is in the second quadrant again, so this will be a minus 1. In the denominator, we get 1 minus, let's see, tangent of 2 pi over 3. Again, this is negative rad 3 times, and then this is going to be -1 again. And then I just simplify this. I'm going to have to rationalize, which isn't going to be fun, but it is what it is. This is, there's 3 negatives here, so I don't want to mess up. Let's say 1 over rad 3. This isn't quite 1. That's not 1. I know it may look like it. I'm going to factor out the negative. Yeah, I'm going to factor out the negative, and I'm going to write this as 1 plus rad 3. It might be easier for me. There's like too many negatives going on. And then I'm going to rationalize, so times 1 plus rad 3, rationalizing the denominator, 1 plus rad 3. Let's hope the answer has rad 3's in it. Yep, it has rad 3's in it, so I think I'm looking good. So I get negative, and then I'm going to multiply this whole thing out. I get 1 plus, when I multiply the insides together, 2 rad 3, and then last times last, I'll get plus 3. Denominator is going to be 1 minus 3. It's a difference of 2 squares. Okay. Yeah, that's no big deal. I like just simplifying. Continue to simplify. Obviously, these negatives are going to cancel out, but I could have factored out a 2 from the top. I don't know why I didn't do that in the first place. This is 2 plus rad 3 over -2. These -2's do cancel out. And then voila, there's the answer, but not quite. It's not the answer in the back of the textbook, which is a little frustrating, but I can explain why. We did not find cotangent. We didn't find cotangent of 113 pi over 12. We found tangent. So unfortunately, we have to take this answer and we have to reciprocate it, which is a little challenging, but we shall continue. So we get 1 over 2 plus rad 3, which would be our answer. We don't like this answer because it's not rationalized. So I multiply by 2 minus rad 3 over 2 minus rad 3, and then hopefully some good stuff happens. On top, obviously 2 minus rad 3. On bottom, I'll get 4 minus 3. That's just 1, so my answer is 2 minus 3. I guess that's kind of cool. Yeah, I like it. Well, I think I've only done 3 problems, and it's been like almost 20 minutes. That's okay. We got 2 more problems. Shooting over to the back side here. Excuse me. So we want to verify each identity. I do like verifying identities. I think this is going to be very challenging, but we'll go with it. And if it works out, awesome. If it doesn't work out, it's not the end of the world. We can't get them all. And we want to get them all. We can't get them all yet. You know, like it's one of those, if we're not able to do this problem now, like we'll come back to it. Give it some time. It'll come to us at some point. All right, I'm going to start with the left. So I'm going to rewrite the left-hand side as always. And then I'm going to go with the right. So I'm just going to use angle addition formula for cosine. I feel like this one I know. The signs are opposite. Sine A times sine B. Sine B, that looks good. All over. Oops, delete. And that's it. I see the answer. Like I can already see it. It's like a one-step thing. The reason why, like, I want, like, okay, so I'm going to put this over 1 because I can do that. Put this over 1. I have a fraction. And in the fraction, I have 1 minus some tangent stuff. Well, for this to go away, I would have to multiply the numerator by 1 over cosine A times cosine B. And I have to multiply the denominator by 1 over cosine A. Cosine A times cosine B because we're multiplying by reciprocals. I wonder if I should split that up. It might be easier. Yeah, I'm going to do that. I might do it in 2 steps. I'm going to do 1 step. So I got 1 cosine A times 1 over cosine B divided by 1 over cosine A times 1 over cosine B. And I'm going to take this, I'm going to distribute to there, and I'm going to distribute to there. So in the numerator, on the first term, when I distribute, I'll basically get a cosine A over cosine A times cosine B over cosine B minus, and then when I distribute the second term, I'll get sine A over cosine A times sine B over cosine B, that is. And then denominator, I get all that like 1 over cosine A times 1 over cosine of B. And then I just simplify everything and I'm done. So like this is going to turn into 1. That's going to turn into 1. 1 times 1 is 1. This is going to turn into tangent A. This is going to turn into tangent B. Oops, there's a tangent B, I swear. And then 1 over cosine of A is just secant A. And 1 over cosine B is just secant B. And there is the right-hand side. We are officially done. It's all good. All good, all good. Whoa, sorry about that. On to the next. This just looks painful. It doesn't look hard. I'm wondering if I should do the right-hand side. I don't know. I don't know what to do on the right-hand side. The left-hand side looks awfully painful, but you know what? Give it the old college try, you know? Okay, so I'm going to do angle addition for sine and cosine. Like, I can't even fit both of them on here. Put it in parentheses. Here we go. Sine A times cosine B plus cosine A times sine B times, I don't want to do this. Not at all. Let's see, sine A times cosine B minus cosine A times sine B. And then I just multiply, and then stuff's supposed to work out. So I'm going to do first times first. That is going to turn into, do a different color here. That's going to turn into sine squared A times cosine squared B. First times first, and then outside times outside. That is a pain. So that's going to turn into plus sine A times cosine B times -1 cosine A times sine B. I think the middle terms are going to cancel out. Pretty sure. Let's see, that's outside times outside. Inside times inside. See, look at this. These guys are going to cancel out. This will be plus. See, this is the minus of the same thing. So you'll get sine A times cosine B times cosine A times sine B. See, these two middle terms are exactly the same. They're actually opposite because one of them has a -1 on them. And so they will cancel out. They'll go away. They'll be like, rup, rup. All right, and then finally, last times last, we'll get negative cosine squared A times sine squared B. And I'm confused. Am I confused? I don't know. I feel like I'm always confused. Just got too old. Okay, let's be smart. Let's be smart. Okay, so everything's in terms of sine. Okay, so I got sine squared A. This just got interesting. Times cosine squared B minus cosine squared A times sine squared B. Okay, there's nothing we can do with that. Like, I don't see anything. But our final answer is all in terms of sine. So let's take these cosine things and turn them into sine. Dude, I know like someone's like, oh, there's an easier way. I just don't see it. Like I just, I'm just flowing, but I think I'm flowing incorrectly. This is 1 minus, let's see what the right-hand side is again. No, we're good. Sine squared B. Looks good. Looks good to me. Minus, okay, oh, I see some stuff canceling out. 1 minus sine squared A. Again, I changed this into 1 minus sine squared A. and this into 1 minus sine squared b times sine squared b. Oh, I see stuff. I'm going to distribute. This is sine squared a minus sine squared a times sine squared b minus, okay, so I'm going to distribute here. This would be minus sine squared b. And I'm going to distribute here. And this will be plus because you got a negative and a negative. That's going to turn to plus sine squared a times sine squared b. And then if you notice, this term and that term cancel out, and you just get sine squared a minus sine squared b. Dude, there has to be an easier way. There's too many things that make mistakes. Man, somehow going from the right. It's a good problem. It's a good problem. We'll just leave it at that. Lots of chances of making mistakes. Thank you, guys.